In continuation with the last lecture, let's do the numerical problems for DTFT. Xn is equals to del of n minus 2. So in this case, find out DTFT. We know that del of n minus 2 is 1 for n is equals to 2. Well, while we going for to calculate the DTFT, so summation part remains for only for one value, that is n is equals to 2 del of n minus 2 e raised to power minus j omega 2. So its value is 1, so e raised to power minus 2 j omega. DTFT discrete time Fourier transform for del n minus 2 is e raised to power 2 minus 2 j omega. Next question is, you have a rectangular pulse xn is equals to 1 for minus n2 n12 plus n1. So while putting the xn values in DTFT formula, x of omega is equals to minus n is equals to minus n12 plus n1 1 e raised to minus j omega n. Now it's a two-sided sequence, minus n1 2 plus n1. So what we do, let m is equals to n plus n1. Okay, so limits also change. Limits now for m is equals to 0 to m is equals to 2n1 e raised to power minus j omega m minus n1. Open this bracket. We have e raised to power j omega n1 outside because summation is for value of m. Open the summation. It will be a finite GP series whose sum is a into 1 minus r raised to power n upon 1 minus r with mod of r less than 1, where n is number of terms. Here we have total 2n1 plus 1 term. So a into 1 minus r is e raised to power minus j omega raised to power 2n plus 1 total number of terms upon 1 minus r e raised to power minus j omega. Okay, now what we will do, take the common from numerator and denominator half value, that is e raised to power minus j omega 2n plus 1 by 2 common from the numerator and e raised to power minus j omega by 2 common from the denominator part. It will help us to make the formula of sine. So multiply by 1 by 2j and divide by 1 by 2j. So upper part will become sine omega 2n plus 1 by 2 and denominator part will become a formula of sine omega by 2, and remaining part will become, if we solve the term, is 1. So x omega is sine omega 2n plus 1 by 2 or n1 plus 1 by 2 sine omega by 2, where n1 is what, highest sample in the given signal, discrete signal. Okay, this formula x omega shows me that the sine omega and sine omega by 2 is, if I plot the curve, it will be continuous and periodic. Okay, so x omega is continuous and periodic, so that's why DTFT of a discrete signal will always result continuous and periodic. Next question is, we have a triangular pulse varies from minus 3 to 3 and value of at minus 3 and 3 0, 2 and minus 2 1, 1 and minus 1 2 and 0 PC value 3. So we have to find out x DTFT. So put out the values minus 3 to 3 x n e raised to minus j omega n. Simply put the value of n is equals to minus 3 to 3. Open the summation, put the values of given, like x of minus 3 is 0, x of minus 2 is 1, x of minus 1 is 2, x of 0 is 3, and so on. So make the formula of sine or cos, multiply by 2, divide by 2, we will get 3 plus 4 cos omega plus 2 cos 2 omega. Okay, next question is, we have a sawtooth waveform. So again varies from minus 3 to 3. Simply put out the formula of DTFT. The summation varies from minus 3 to 3. Open the summation, and now we will multiply by and divide by 2j because we have minus side inside the terms. So it will become the sine formula. So we will get minus 6j sine 3 omega minus 4j sine 2 omega minus 2j sine 2 omega. This is the DTFT of a sawtooth wave, given sawtooth waveform. Now the important thing is that the periodicity of DTFT, important, take care of this thing. We know that a raised to power n un DTFT is 1 upon 1 by 1 minus a e raised to power minus j omega, that is x of omega. Okay, DTFT is represented by x of omega. If we go for x of omega plus 2 pi k, where k is integer value, so it is 1 upon 1 minus a e raised to power j, omega को replace कर दो by omega plus 2 pi k. Open this bracket, omega e raised to power minus j 2 pi k is always 1. So it will again 1 upon a e raised to power minus j, that is equals to x omega. This shows that x of omega is equals to x of omega plus 2 pi k, where x of omega is periodic signal and 2 pi k is the fundamental time period, that is 2 pi, and x of omega is always analysis between minus pi to pi due to the symmetry of minus pi to pi. Okay, and the complete time period is 2 pi. That's why we can say that while calculating inverse DTFT, we have the formula 1 by 2 pi x omega varies from minus pi to pi e raised to power j omega and d omega. Okay, next question is for inverse, calculating inverse DTFT. Like we have x omega is equals to del omega. What will be the inverse DTFT? That is xn. Put out the formula 1 by 2 pi minus pi to pi x omega. X omega is what? Del omega. Del omega is exist only for one point, that is omega is equals to 0. So 1 by 2 pi, this complete part will become 1, and e raised to power 0 is 1. So 1 by 2 pi. Del omega inverse DTFT is 1 by 2 pi. Take 2 pi is constant, take to the right hand side, or you can say that DTFT of 1 is 2 pi del omega. Next question is x of omega is del omega minus omega naught. That means we have an impulse shifted at omega naught. Okay, similarly we can go for del of omega plus omega naught. Important question, find x of n. Put out the value. We know that for the integration part, this impulse exists only at omega is equals to omega naught. So answer will be e raised to power j omega naught n divided by 2 pi, and integration part complete will become 1. So we can say that del omega minus omega naught having inverse DTFT is e raised to power j omega naught n by 2 pi. Take 2 pi constant, 2 pi to the right hand side. So we will have result right now, e raised to power j omega naught n having DTFT 2 pi del omega minus omega naught. Now we know that e raised to power j omega naught having 2 pi del omega minus omega naught. Similarly, e raised to power minus j omega naught n will have 2 pi del omega plus omega naught. So for some, add these two value and divide by 2, we will get the answer for cos omega n DTFT will be pi del omega minus omega naught plus del omega plus omega naught. Similarly, we have sin omega naught n, multiply and divide by 2j, so we will get pi j del omega minus omega naught minus del omega plus omega naught. Now two important point is there, just similar to the CTFT. We have minus infinity to infinity mode of x t dt should have finite value. This is the condition for the existence of DTFT. Similarly, DTFT is the same condition, like summation and minus infinity to infinity mode of xn should be finite. Now again, DTFT is for three condition cases are there. First, we generally DTFT is defined for aperiodic signal. Fine. Second, defined for aperiodic signal. Second, limited defined for signal like sin omega naught n, cos omega naught n, but defined at least for one value of omega in the period minus pi to pi. And third case is undefined for the signal like 2 raised to power n un, because here it is a growing exponential. If we find out the summation for that one, it will become infinite. So this is the third case, undefined for the signal like 2 raised to power n un or minus 1 by 2 raised to power n u of minus n minus 1. In the next lecture, we will go for the properties of DTFT.